Steel. Perhaps no other material has been so important in the industrial development of our civilization, in the creation of our high standard of material wealth. Our world is filled with steel objects of an endless variety of shapes and sizes. But they didn't assume the shape naturally. They had to be made. York, South Carolina is the home of the Ajax York facility. Here rings are manufactured for any and all uses. For wherever and whatever purpose, heavy steel must take a ring shape. For each type of ring Ajax makes, detailed records are kept, listing material, physical dimensions, tooling instructions, and the amount of raw steel required to produce each ring. Steel billets are used as the source of raw material. They come in many diameters and in many grades of carbon and alloy steel. Once it is determined which particular billet to use, it is brought into the plant by an overhead crane. The weight per linear inch of each size billet is a known factor, so the proper length of raw steel needed to yield a desired weight can be measured. Carbide-tipped blades on large circular saws cut the billets into blocks of the required weight. The blocks are then loaded into a gas-fired furnace where they're heated until they reach the proper forging temperature of approximately 2,300 degrees Fahrenheit. The steel is now ready to be forged. During the heating process, scale forms on the outside of the blocks. This scale is removed from the ends of the block by the means of a chain descaler. The block is then upset to a predetermined height on a 1,000-ton press, thus removing the remaining scale. The preform is then transferred to a 2,700-ton two-station blanking press, where it is first indented, then it is pierced, producing a finished blank. Because of the heat loss during this process, the blank is loaded into a reheat furnace to return it to forging temperature. The blanking and rolling of the ring are controlled from a control room high above the shop floor. The reheated blank is loaded onto a 100-ton radial, 80-ton axial ring mill, a sophisticated piece of equipment designed specifically for the purpose of manufacturing seamless rolled ring forgings. Here a mandrel is inserted into the blank. The mandrel brings the hot blank against a large motor-driven main roll. When contact is made, the blank begins to rotate. Smaller centering rolls hold the blank in place. The mandrel continues to apply pressure toward the main roll, reducing the wall of the blank in the process. Tapered axial rolls above and below the blank reduce its height. As the wall thickness and height are reduced, the diameter of the hot ring grows. In the control room, digital readouts show the operator the wall thickness, height, and inside and outside diameters of the ring as it is being rolled. When the required dimensions are reached, the machine releases the ring, and a worker on the shop floor manually verifies the outside diameter and inside diameter. The ring is stamped for identification, then removed from the ring mill and set aside to cool. Ajax York uses a different process for high-volume production of small rings. To make smaller rings, smaller diameter material is used. The blocks are cut. An inline scale checks the weight of the block to assure that it is in tolerance. From here, the block continues to the automatic loading tray. The job is now ready for the forging line. Cold steel enters the induction heater at one end and in minutes emerges from the other end, only a few feet away, at the proper forging temperature. Since a smaller mass of steel loses its heat faster than a larger one, these rings must be formed very quickly to prevent loss of formability. Automated production is the answer. A robotic swivel manipulator quickly grabs the hot block and feeds it to an automatic 1,000-ton blanking press, which upsets, indents, and pierces the blank. A conveyor carries the blank to an automatic 40-ton radial, 25-ton axial ring mill, where it is rolled to size in much the same manner as on the large ring mill. For some customers, the rings at this point constitute a finished product. but for others, further processing may be required. For instance, rings can be heat-treated to increase their hardness. This involves heating the ring to approximately 1550 degrees Fahrenheit and then quenching it in a coolant. Internal stresses are created during this process, so the ring must be heated again to a lower temperature to temper its hardness. Annealing and normalizing can also be done in these furnaces. In order to make sure that all residual scale is removed from the finished rings, they are cleaned in a shock blast. Next, the rings are 100% inspected to ensure sufficient machining stock for guaranteed cleanup, whether machined by Ajax or their customer. Ajax is equipped with vertical turret lathes with turning capabilities up to 120 inches. Some rings are rough-turned to remove the as-forged surface. Others are machined to achieve more critical tolerances or a very specific shape. At Ajax York, the emphasis is on quality. Rings are tested and retested to assure that they meet standards for composition, hardness, size, and shape. Production of a quality product is the name of the game at Ajax. Our customer service department works to handle customers' orders and questions and to see that these orders are shipped on time. Rings from Ajax York find their way into the real world in a multitude of uses. Ajax rings are processed into bearing races for a wide variety of industrial applications. Gears made from Ajax rings go into off-highway vehicle power transmissions. Assemblies built around Ajax rings allow motor graders to rotate their blades. Crushers turn rocks into tiny pebbles between rings from Ajax. Tunneling equipment used to bore beneath the earth is tipped with steel rings from Ajax. The durable steel objects in our world were made by hardworking people with a dedication to quality. The next time you see a steel ring, it may have been made by Ajax.